Hey, what's up, guys? Chung here again. So today, let's take a look at this hard LeetCode problem, number 420, strong password checker. You know, this one is one of the hard problem among all the hard problems. It's a very tricky one. You guys can see it from the accepted percentage here, right? I mean, this one's gonna be a pretty long videos. I mean, to be honest, I highly doubt you will get this problem during like a real interview. But just like uh, to keep the spirit of learnings, let's still try to understand this problem. Okay. So and cool. Let's start. So a password is considered strong if below conditions are all met. Basically, we have three conditions to be able to make one string a strong password. Okay. The first one, the length has to be between 6 and 20. Okay. And second, it must contain at least one lower letter, one upper letter, and one digit. Third, you must it cannot contain any three consecutive like strings. Okay, basically the consecutive duplicate strings more than three consecutive strings, and they ask you to return the minimum changes required to make a strong password. If it is already strong, return 0. Okay. And insertion, deletion, and replacement are all considered as one change. Uh, so I think the first thing comes to my mind is because every time when I see this insertion, deletion, and replacement for like a string, I think the first thing comes to my mind is like gonna be a DP solution, and and indeed this problem can be solved with DP. And yeah, so let's try to solve this one with a DP first. So here, I think a top-down DP is more intuitive, and the hard part for this DP is it has many properties for state. Okay, basically, every time we have a DP here, right? The DP here, we have we will have like some properties to identify as a unique statement here, state, right? So for this problem, first one is the index. Okay, I'll just tell you guys the answer here. First one is index. Second one is the what? It's the number of the strings. We have already uh that's the number of index for the so why number of numbers numbers of string. And second one is the lowercase flag. Okay, lowercase flag, uppercase flag, and then the what? The digit flag. Okay, the digit flag. So why we need both index and the number of strings in this case? Um, the reason is because we we might need to do the insert. Okay. Mm, and let's say for example, if we have like A, B, C, D, E, and F. Let's say we're at like D here. Okay. So we're at D here. Let's say when we try all the possible uh, scenarios here, one of them is insert, right? Let's say we're trying to insert the like insert like a Z, right? Insert a Z here in here. So so it means that we are like processing Z's instead of D here. So which means like the in that case, the index will stay the same, will still be the index, but the number of strings will plus one. That's why we need both the index and number of strings. And the reason we need the index is because we need to know what's the current strings we are processing here. And the reason we are keeping the number of strings here, besides the index, is we're gonna use the number of strings to do early terminations when this like the number of strings is reached the 20s, right? So because we don't want like a string that's more than 20. Okay, cool. So that's that. And also since we have the third condition here, right? So which means we need to have like a two more properties here for each DP, which is going to be the last character and what and the second last character, second last character. Okay, yeah, basically that's going to be our DP state here, and at each state, right? So for the top down, once you have defined the DP state here, you also need to define what's the base case. Okay, so the base case is it's between 6 and 20, basically, right? So one base case is 20. I mean, which means like I already told you guys. So when the number of strings is greater than 20, then we should simply return. So what we should return in this case, I mean, since it's asking us to find the minimum changes, so when the base case is gonna be we're gonna return the maximum number. Okay, and that's the first base case. So how about the second one? Since we'll be doing both the insert and the insert will lead us to the number of strings. Okay, and another base case is the 6 here, and the 6 here. Yes. So basically, when the index uh uh so the second base case is like say the index. If the index is the same as the length of the string here, okay, it means that we have already traversed to the end of the string, okay, and then and for so then for that one we just need to check, right, if the current string is a valid one or not. How can we check that? Basically, we check if the number uh, if the numbers of string is greater than 6, equal greater than 6, or and that it has a lowercase, uppercase, and digits, right? And then we know, okay, it's a valid one. When it's a valid one, what do? We return 0. Okay. Otherwise, we return the maximum. Okay. Basically, that's the two base case. And other than that, it's just at each state, right? We'll basically try all the possible scenarios, which is the insertion, deletion, and the replacement. Yeah. And when we do the insert, delete is the easiest one. Okay. And for the insert and replacement, there are like also three possible different scenarios because we can either insert like a lowercase or insert an uppercase or insert a digit. Same thing for the replacement. Okay. And yeah, I think that's the basic idea for the DP here, but the implementation is gonna be a tedious. Okay, just bear with me. I'll try to code these things real quick here. Uh, and of course, this one is not gonna be the fastest one, as you guys can see, because actually we're trying all the possibilities, right? We're trying all the possibilities. Then how many possibilities do we have here? It's going to be the index plus the numbers of strings, which is the length of s, plus lowercase, uppercase, that's what. So here we have like n, things things n here, right? So here 26, right? 26. How about the digits? Digits from 1 to maybe 10 here, like, and the last character, right? So the last character and the first character, this is going to be something like, since we're not allowed to have like 3 consecutive letters, right? Uh, yeah, I mean, something like this, right? I mean, it's hard to measure the real complexity, but you guys can see we have we're basically multiply uh, all these possible parameters so to get the total the scenarios, right? Which will be pretty big. Anyway, time for coding. Okay, DP. Okay, index, right? Num of characters. I'll call this, and then has lower, has upper, has digit. Okay, and then we have a last character, and we have a second and last character. Okay, and yeah, basically, for the deep top-down DP, we're gonna use the DP with a cache with a memorization, and for in Python, there's like quick basically a shorthand way of doing this. Basically, you just define this RU cache equals to none, and so the Python can basically handle this cache for you. Basically, every time when it sees the same you calling the DP the same method with the same parameters, it will just give you the result that this like method had already returned previously. And LRU cache equals to none means that it will never, this is like the least recent used like policy for cache, right? If we set to none, it means that we basically telling it, okay, we want to keep all the cache results, okay, so that we don't have to define those memorization like parameters. Okay, like I said, so the num of character when it's greater than 20, right? We return what? Sys dot max size, right? And then if the index is equal to n, sorry, where's n? We don't have n here. Okay, so n is to the length of s, and here we simply return the 0 dp 0 0 has lower false false false. Last character is empty. Second last character is also empty. Okay, so that's that. And when we reach the end, we simply check, right? We simply check if the num of character is smaller than 6. Oh, it's greater or equal than 6, and has lower, and has upper, and has digit. Okay, then we know we can return 0, right? That's the base case. Basically, it means that we don't need to do anything here. Okay. Uh, yeah, I think one of the issue here is that how can we make sure, right? There's no consecutive A's in this case. I mean, the answer is uh, since we are trying all the possible, since we're trying all the possible scenarios, it's enough for us to only check those those the first one and two conditions in this case, because we will have like other like scenarios which also be reaching this reaching this state that will give us that will contains the non-consecutive duplicated strings. And since we are exploring all the scenarios, I mean, we will be getting the minimum one. So basically, we will be also traversing that scenario. Okay. Else, else we return like system max size, which means it's an invalid state. Okay. Now, answer equals to system max size. Okay. And then let's do the first one is to keep, right? Basically, uh, to keep means what? To keep means we keep the current string, right? Current character, we're not removing it or insert. Basically, we do nothing. We just keep going to the left, going to the next one, which means um, the conditions to keep the current one is to what? To if the current one is not, if there's no three consecutive duplicated letters, right, at the current moment. Basically, if the previously two are all A here, if the third one is also A, it means that we cannot keep it. Okay, but if this one is not the current one, right, we can keep it. So that's the only conditions we need to check. Basically, if not, uh, how can I, uh, if as index is not equal to the what to the last character, or as index is not equal to the second last character. Okay, yeah, then okay, we can keep it. So the way we keep it, we just do a minimum of the answer of what the DP. So to keep it, we don't need to do anything. Oh, by the way, so this has lowercase and has uppercase, has digits. It means that uh, after, like, before processing the current character, right? Have we seen like a lowercase, or have we seen an uppercase, or have we seen the current what, and also the what's the number of characters we had already processed so far? So it means that index plus one, okay, and then the num uh, of characters also plus one, okay, and then so how do we set the has lower, has upper? It depends on the if the current one is uppercase or lowercase, right? So which means I'm gonna do this. Uh, Basically, if the has lower or s dot index dot is lower, okay. Uh, Excuse me. So same thing for the other two flags here. Okay, I'm gonna copy and paste here. Uh, so has upper, okay, and is upper has digits, okay. Basically, we're doing our OR here, right? So any of them is true, and then it is true. Okay, so that's that. And the second one, oh, and then the way we're doing actually I'll do this. So basically, the character is equal to what? Equals to the s dot index, right? So I'm gonna save this one, so I don't have to do it every time here. Okay. All right. So C C. So now the current one will become the last character, and the last character will becomes to the second last character. Okay, so that's how we rotate these things, right? Okay, if we keep this one, right? So the index will plus one, and the number of characters will also plus one. Now is the tricky part. Insert. Uh, okay, insert. Uh, insert lowercase. Okay. I'm gonna copy this one here. So, like I said, so to insert, right? So to insert, it means that we're processing the ones we just inserted. Okay. So it means that we still cannot move to the index to the next index because the next one will still be processing the index. Basically, we're adding one like of the letters right before processing the current one, as if like we're processing the inserted character in this case. Okay, that's why if we insert a lowercase, this one is going to be true. Okay, yeah, and oh, and one more thing here. So since we do the keep, we don't need to add one here, right? But when we do the insert, we're counting like the changes, right? So in this case, it's going to be a plus one, right? That's to insert lowercase. I think same thing for the uppercase and digits. Uh, insert uppercase and insert digits. So here, okay. Let's see. Hmm. Yeah, okay, so since we're like inserting the lowercase, right? I mean, we know we're inserting a lowercase, so then in that case, we can just keep the uh, the uppercase and digits, right? Here. So here is going to be true here because we know it will not be a uppercase or a digit. That's why we can simply use the previously flag here. And same thing for this, okay, but in this case, uppercase, so this one is going to be true. And here, true. Okay, and each one consider as a change. Okay, so that's insert. How about the delete? I think the delete is fairly easy. Basically, the answer, I'm gonna still copy these things here. So the delete means that we're deleting the current character, which means that the number of strings will be what? Will be will not be increased. Okay, but here we're increasing it by one. The index will be increased by one. And oh, sorry. So for the insert, I'm sorry. For the insert, then the last character, sorry, the last character will be what? Will be the ones we just inserted. But what we're inserting here, uh, I guess we can insert anything, right? Uh, as long as it's not the same as the previous as the last character, I think that's fine. I think we can do a Y maybe if last character goes to Z, right? Else Z. Yeah. Uh, uppercase. This is Y, right? I mean else else Z. How about this, right? So that this is the uppercase, um, the digits, right? So digits, I think it's like maybe 8, right? If last character go to 9, right? Else 8, else 8, okay? So then the delete is fine. Delete basically the last one. So the delete, it's you're deleting the current one, which means the second and the second last one doesn't change. Okay. Okay. Last. Is it? Uh. The naming is like really confusing. Jeez. Last character. Okay, fine. All right. Uh, Let me try to run it, see if there's any compiling errors here. Yeah. So because I'm going to do a lot of copy and paste, so I don't want to do it over and over. Line 10 has. Okay. Yeah. Okay. Okay. Cool. So that's a delete, right? And now for the replacement, same thing for the replacement. We have 3 scenarios here. Okay. And change to, right? Change to digits. So for the replacement, and what does it mean, right? It means that it's +1, but okay. Mm, Same thing here. +1, that +1, and true, true, and same. Yeah, the only difference is that I think comparing with the keep is that we are like setting this flag here. So this is just +1, I guess. Everything else should be the same. Okay. Yep. I think that's it, right? Basically, as you guys can see, we are basically we're trying all the possible scenarios here. Run it. Uh, okay. I think here, I mean, if the n equals to 0, we simply we return 6. Okay. That's one of the scenario we didn't consider. And submit here. Wait, last. Okay, here. Okay. What? Oh, sorry. I forgot to return the answer in the end. Okay. Otherwise, since we're using this like cache thing, right, we have to return. Otherwise, the cache won't have the result. What? 2, 3? Um, to keep. Okay, let's see. Uh, keep adding that. We don't add one here, but for the insert, we true has upper, index here has lower, has upper, has this, and then delete. Delete is +1. Oh, sorry, the delete. Okay, I think I forgot to copy these things back here. Yeah. Delete, we're not changing anything of here, basically. Let's try to run it again. Yeah. All right, passed. All right. See, it's only beating faster than 5% because we are actually exploring all the possible ways. But at least that's one of the solutions here, right? So I mean, it's anyway. I know it's like very tedious, but that's one of the solution. Okay. Okay. Next. Okay. So the next one is more. It's even trickier. Basically, the next one will be like the greedy method. And okay, so okay, I'll try to finish the second one sooner. I know it's already like 30 minutes in here. So okay, so the second solution is a greedy uh, idea here. Mm. So a few things you guys need to understand. The first one is the when you have like a few number. Let's say we have one A and A. Okay. So when you have A, and A, so the quickest way to make this one like the what the a valid one is to replace one, right? Well, actually, you know what? Actually, here, I think this is a better example here. Let's say we have A, we have five A's here. So the best way of making this five A's like a valid password is to replace this one in the middle, like replace this one to like a B or to B or something. Okay. And so what's the scenario of this one? That's the if the length, right? If the length is divided by 3 is equal to what? Equals to uh I'm sorry. Okay, so I think basically what I'm trying to say is sorry, I know the second one is it's hard to explain. Is the to have five A's the five A's is the most efficient way, right? Basically, because at the five A's here, all we need to do is we just need to like replace the, the middle one with a different one so that we can separate those two parts. Okay, and or you can think it in this way. Let's say every time when you have three consecutive A's here, right? You need to do something for this for this one. Okay, and let's say you have a three consecutive A's and you have a three A, and A, right? So we have six A's here. So what's the best approach to convert this one? To convert this one to like a valid one or like nine A's here. Mm. So the quickest way is to convert this case into this one to delete some A's, right? So that it can be separate. It can be replaced by it can be replaced in the middle one, the middle one here, so that uh, we just need to like remove. We just need to remove like the what to reduce the this amount from the n per mod by 3 equal to 0 to this format. Okay, which will be a what? We are gonna remove one 1. Yeah, basically we just need to remove one letter from this, so that I know it's in the format of this one, right? And then we can simply replace this one with B and this one with B. Okay, see, so that's the best approach, right? And the second one is this. The second one is this, like if we have like two more, right? A, and A, one more A's. Same thing, right? In this case, we need to remove two letters A's to make this one, to make the rest, the patterns, the best pattern. So we can replace this one and this one, okay? And that's the basic idea for the greedy uh, solution here. And what we need to do is we have to pre-process all the consecutive like duplicated letter consecutive duplicated strings here whose like length is greater or equal than 3. And then we will be basically will be counting how many of them are having the pattern of n divided mod by 3 equals 0, and how many of them have the patterns of this one. Okay. Yeah, so that I mean when we try to delete them, we can follow the patterns, right, to delete. And that's, you know, the things we have been discussing here is for the case of the n is greater than 20. Okay. So for the case of n is smaller than 20, it's much easier because all we need to do is, let's say for example, if we have a case like the n is smaller than 6, okay, then what we need to do? The first scenario is we just need to uh 6 minus n. Okay, basically that's the minimum that's the minimum mm, the minimum letters we need to insert. We need to insert into the to make it at least 6 letters. Okay, and the second one is mm, the second scenario is that how many we also need to check if this current one has any those lower letter uppercase or upper letter or the digits. Basically, we have three types here, three types, and we also need to like to see how many types the current string is missing here, and we just need to do like the missing types here, the missing types. The missing types between the we have to get the maximum of them. Okay, so that's the first, that's the n minor n smaller than 6 case. We just need to get the maximum between the 6 minus n and the missing type. So why is that? Because it's because okay, let's for example we have a here, okay, and the length is the n is 5, so the 6 minus 1 is 1. But how about the missing types? How many missing types we have here? It's 2. That's why to make this one like at least uh to make this one a strong password is we need to make at least 2 changes, which requires what? Requires the you know, when we do the replacement for this one, we can replace it to like a digit, like to a upper B here, uppercase B here, so that it can satisfy both the second and one of the two conditions, right? So basically we just need to replace this one to B and then we add one more one here. See, that's how we make this one, the n minus 6 a case, like a valid one. And how about between 6 and 20? So between 6 and 20 is also like kind of straightforward because we just need to, because for every 3 consecutive letters we need to make one change. Okay, and while we're pre-processing the numbers of consecutive numbers, we just need to do the same thing here. Basically we'll do like the missing types, missing types plus the number of changes we need to make. We also do a max of them. So because when we do the changes here, when we do the change, we can always change this one to one of the missing types here, right? That's why we can just do a maximum of changes plus the missing types. In case the changes is less smaller than the missing types, then we need to use the missing types here. Okay, I know it's confusing. I agree. Let me try to maybe explain a little bit more while I'm implementing this greedy solution here. Okay, cool. So, all right. So the first thing first, we need to get the missing types because as you guys can see, we'll be using the missing types as a benchmark later on. So at the beginning, the missing types is 3. Okay, and then every time we have like a different type, we just decrease it by 1. Basically, if the C is lower, okay, for C in S, okay, then we're missing types -1. Okay, same thing. I'm gonna copy and paste this one here. It's upper, okay. It's digit, okay. And then we have swaps, okay, or we have change, okay. 0, and we also need this like remove once, okay, equals to 0, and remove 2 equals to 0. So, and let's pre-process the strings to gather all the repeating groups whose length is greater than 3, equal or greater than 3. So, and to that's why we start from I equals to 2. Okay, so basically if the Si is equal to the I minus 1 equals to the Si minus 2, then we know, okay, we have find the group, right? Then the length is equal to 2, but we don't want to stop here because we want to get the total length, right? We want to see what's the biggest length here. So that's why we do a I minus smaller than n, and I is greater than Si minus 1. Basically, we'll keep expanding this repeated, the duplicated string until it's not duplicated anymore. Okay. All right. So this one, maybe I should use like a length here. Length. Okay. So now we have the length for this duplicated the duplicated string here. For example, we have a and a. Okay, and then how many changes we need to make here, right? Like I said, every three consecutive letters, we need to make one change. Okay, that's why at the beginning, right, the changes be called will be the length divided by 3. Okay, and we also need to gather how many of them are in the pattern of the 3 here. And then we remove 1 plus 1. Okay, else if the length of 3 is equal to 1, and then we remove the 2 plus 1. So here basically we're gathering like the number of the patterns for this one and for this one, because for the pattern of the length can be divided by 0, and then we know, okay, we can remove one letter, right? We remove one letter so that meanwhile we also like removing one of the changes. We can remove the changes by 1 here. uh yeah, so basically what I mean is that, with this 6 here, to make them not to match the third conditions, you need to make two swaps, two changes. Basically, you need to change uh, basically either here or here, right? Or anywhere, okay? To make them like not having the 3 consecutive same letters. But by removing one of the letters here, right? By removing one of the letters here, you only need uh, to change one place, which is the ones in the middle, right? Because basically the 2 on the left and 2 on the right side are the most efficient way of making of the change, so that it can satisfy the third condition. So that's what I mean here, right? Basically, by removing for this pattern, if we remove one letters, then we can instead of making two changes, we can just make one change. Okay, and for this patterns, right, by removing two letters from the end, like this, for example, this one, right, by removing this two, we can also uh, because for in these patterns we also need to make two changes, because like this, we change this one and we also change this one. Okay, so by removing this two, we can also reduce the changes by 1. Okay, since we are removing the letters, right? Since we are removing the letters, like for the case if the n is greater than 20, we have to find a best strategy to remove the letters. Okay, that's why we're keeping all these kind of parameters here. Okay, cool. So that's that. And else, right? If they're not duplicated, we just keep going. Okay. Now since we have pre-processed all the changes we need, that's the initial change, right? Because without removing any of the letters. Okay. Now for the case of n smaller than 6, okay, so that's the n smaller than 6 case. We have this. We have a missing types, and the 6 minus n. Basically, whichever is bigger is our result. Okay, because it's 6, and for the 6, and for the 6, since it needs to include 3 types, right? So with both 3 types appear in 6 strings, right? We can simply satisfy the third conditions here. That's why. Okay, and smaller than 20. That's the 20 cases. So for 20 cases, since we don't need to delete, remember that, right? So if we don't need to delete it, our best strategy is just a swap. Okay. So we simply just need to return the maximum missing types and what and the change. Okay, so by the change means swap, right? Swap, change the letter from one to the other. So if the length is between 6 and 20, the only things we need to do is we'll try to swap, because the reason being, like the same thing for this one. When we do the change here, we can always change that letter to one of the missing types. Okay, that's our best strategy for the case of the n in the range of between 6 and 20. Now the last one. The last one is the most difficult one. Basically, if the length is greater than 20, we have to delete. Okay, so let's do this. The delete equals to what? N minus 20. We know that's the numbers we have to delete, and which means that in the end we'll be returning the delete plus something. Okay, because this is our base case, right? So and so to delete, like I said, we will try to delete uh, the remove one case first, because uh, that's the best strategy. Basically, we can remove because remember the remove also counted like a change. Uh, okay, and I'm sorry. So sorry, not so we sorry we already have the base case here. So when we do the remove, right, we want to remove a minimum one so that we can reduce the changes here, which is the ones. I know this part is confusing. Basically here, so delete and the remove one. Basically, what it's doing here is that, if there's any deletes, right? If there's any deletes here, and uh, I mean, if we only basically if from the remove one, basically by removing one of the letters, we can reduce the changes by one, right? And we also want to bound it with the deletes here, because if the deletes is smaller than the remove ones count, right? We can simply we should simply like bound this one with the deletes here, because we don't want to remove it smaller than 20. That's our base case. And then once we have removed the first pattern here, we need to process the second pattern, which is so now the deletes becomes what? Becomes to the let's do this, deletes minus the removed one. Okay, because at this moment we have already removed this number of the letters, so that we have this one. We have this plus 0. Okay, and now the remove 2. Okay, times 2 and divided by 2. So what this one is doing is basically after removing this number of one letters, right? We have this many of letters left. Okay, but we don't want it. We want to make sure this one is greater than 0. Okay, and then now we need to remove two letters for this remove two patterns. Okay, and by removing two letters here, right? Basically, for removing every two letters, we are removing like we're removing one changes here. That's why we do a divided by two here. And the third one is that every time once we have processed both the first one and second one cases, the third one is that we have to remove three letters to reduce one changes here. That's that's a case of the a a a uh, a and a. That's this case. So for this case, we need to remove three letters because at right now, I mean, we need like how many changes we need to make? We have to make this one and two, right? And to make it like to reduce one changes here, we have to remove three letters so that we only need to make one change. Okay, so here we just need to delete. Now the remaining deletes is this: remove one minus remove two times two, right? So here and also we also want it bounded to zero, and then we divide it by three. Okay, and now in the end we simply do a missing type here, missing, same thing for the missing types plus the change. So whatever left in the changes here is the changes we still need to make after deleting this number of the letters. Okay. Okay, right. Let's try to run this code here. Okay, submit. All right, so this one is much faster, but I know this one is even for me. I got confused. I got confused sometimes for this one, but uh, for anyone that's still watching the videos, I really appreciate that. So I know it's a hard problem, and especially for the second one. I think for the first one, I mean for the DP ones, even though it's like kind of long, but it once you understand each of the state, does each property stand for? It's not that hard to basically to follow the logic here. But for the second one, I mean, it's really confusing. Basically, we just use the greedy method. We just try to come up with the best strategy to delete the letters, right? While when the length is greater than 20, and while we're doing the deletion here, we also keep track of the remaining changes we need to make. So that in the end, after deleting all those the letters here, we because again we don't want to delete the letters uh to be to less than 20. Basically, after deleting the letters for all three scenarios, whatever changes it's left is the changes we still need to make. Okay, and that's gonna be our best strategy, right? Because the delete is the unavoidable uh, changes, and after deleting, after following our best approach to make the deletions, now the rest is the swap we still need to make. Yeah, I think that's pretty much it is for this problem. Yeah. Okay, so it's almost an hour. I think that's the longest video I ever recorded. Okay, thank you so much for watching this long videos, guys, and I really appreciate that. And stay tuned. I'll see you guys soon. Bye bye.